Welcome everybody. This is a new lecture on global variables. It complements one of lecture that we saw in the previous module. What we will see during this lecture is that global variables can be disguised. So sometimes we don't see them at first, but they still exist. And we will study several cases that happen in Pharo or that has been discussed in the mailing list. So the idea is that we want to show that globals are not nice because they are globally shared. We saw that in the previous lecture. They are difficult to test. And in this lecture, we really want to show that they can have different forms. And for that, we will really study one by one four case studies. And we will show that when you don't have a global variables, you can dispatch. And when you have a global, you cannot. So let's start. So this is what I call the autopsy of an error. So in Pharo code, in the past, we often add this expression, Smalltalk icon names, things like that. So let me explain what is it. Smalltalk, this is a global variable that is a namespace that contains all the classes of Smalltalk and also some globals that point to some objects. So here, the expression Smalltalk icons refer to an icon manager. And here the code means, okay, global icon manager, please give me the icon name window. So I'm stressing the fact that this is a global variable. Normally, you just read it like that. Okay, so what can we conclude from this? First, this guy is a global variable. What if I want to have a different set of icons that is specific to my specific application? I cannot. I will have to go and patch this global icon provider, and then it means that any user of the icon that I change will be impacted. So basically, I cannot compare, for example, if I am doing a design, often you want to have a black theme or a white theme with different icon sets. You cannot. You cannot because there is only one. In the community, some people propose the following solution. They said, oh, you know, a better way this is to do that. So what is it? What does it mean? It means that they send the message as icon to a symbol. So in fact, these people, they propose to extend the class symbol with a new method that was basically doing the same thing here. So in Pharo, when I mean extend, it means that in Pharo, a package can add a method to another class that is not packaged in this package. So this means like I said, oh, dear class there, I want that you get this method, but only when this package is loaded. So that's why we can add methods in kernel classes, because symbol is a kernel classes. So let's analyze the situation. This solution does not duplicate this expression everywhere. So this is already something, because it means that there is only one place in the system where I can change it if I want, but still this is a global. I still cannot have two icon sets in the system. So what we see is that a global variable can be disguised, but it is still there. There is one place here where we can edit it, but fundamentally, this is still one instance variable. And this was based on message passing. So you could say, oh, yes, I send a message, so this is okay. No, there is only one icon table in this system. We cannot dispatch to a different object. There is no different object. There is only here one symbol. So this means that my application cannot extend or slightly change icons because I will have impact everywhere. I cannot have two icon sets at the same place. So now you should wonder, what is the solution? So a better approach, this is that the framework, here for example, the application that is holding the menu, propose a method that is called icon named that can be dispatched to this guy. And then this icon name methods will just do some things and it can ask, oh, I have an icon provider, and I will ask the icon to this provider. So like that, every application can say, oh, I want to be configured with a different icon set and manage that. So this is the way it is done in the spec framework to build application in Pharo. We don't use a global variable. Every application have its own icon provider, and then we can dispatch there. So it is modular because every application can decide what they want to do, how they want to be configured. Each receiver may do something different, and they can be configured silently, but still we will share the same common behavior. So this is the reuse as it should be done. So when we want to access programmatically a class for doing a script or things that are a bit strange in Pharo, we ask the namespace. We say, namespace, give me all the globals in the system. This is a dictionary, basically, that is holding a reference to classes, and give me the class that is named a point. So people were saying, oh, this is too long, I have to type this code and things like that. And they wanted to have a shorter version for scripting. So what they proposed something like that. They said, no, you know, we want again to extend the symbol with a new method and do that. And of course, this is shorter, but this is not good. So there is a difference between the two. I hope that now you see it, but let's look at the difference. So I have the same limit as before. Global is an entry point. And when I write point as classes, I have only one symbol in the system, one class. This is an instance of the class symbol. So I cannot have multiple implementation. I cannot dispatch. I have only one place. So imagine that, for example, I would like to access a class that is remote. As class will only access the one in the system. I cannot dispatch. I only have one object here, this symbol. It could be, by the way, it could be a rectangle. That would be the same. Huh? When I say that we have multiple, let's be clear, we have multiple instances, but we have only one class. So if you remember the first lecture of this MOOC, then there is no way that I can dispatch to a different behavior. Here, what this message implies, this is that there is only one namespace in the system. There is no way that I can dispatch to another place. So you see, this is again disguised global variable, and that's why we were really against this the introduction and the use of as class in Pharo. People can use that if they want, but we don't want to use it internally in the system because we want to be able, for example, to browse Pharo code that are running on other machines, and if we do that, we cannot. So the possible solution, this is just to delegate to the system. We could say, oh, you know, self-class environment. Environment means, okay, to a class, go to your namespace and look for a class. And in that case, the class can have different environment. It can be configured differently. So let's look at a fourth case study. When you browse the Pharo code, sometimes you see these kinds of code, and you will start to understand the pattern. So this is the code to when you want to browse a method. It said, oh, if for example here said, okay, what is the current class or meta class? If this is not nil, I will invoke the browser and open the class with the current message, and then we will be able to see all the implementers of that message. Again, now you should know, and you should understand. Aha! Again, the ugly global variable, because here Smalltalk tools this is pointing to a tool registry mechanism. So there is one in the system, and we will ask the browser in that. So again, one single entry point. Everybody will refer to this single entry point, and this is monolithic thinking. So this means that you cannot have, you cannot exercise code that will open this browser and that you would get two different browsers because you are trying to see what is the best one that will fit the scenario. So you can have only one tool set possible at the same time. This could be okay, but we should really understand that this is what it means. So, and you see, this is not because I send a message to a global that, in fact, I'm not manipulating conceptually a global variable. So what is the solution? A possible solution, this is, okay, this means that the ID of Pharo should be defined as an application, and that this application should, for example, have a tool environment instance variable, instantiate the tool environment, and then after, just do that. Which will be okay, because it means that each application will be able to dispatch. We could even have a different tool environment for a given application. What we should consider here is that there are still some points to consider in this lecture. So with a global variable, when it changes, all its users are updated for free. So which is nice. You don't have to go over and say, okay, you change, you change, you change. No, because there is only one place centralized where everybody refers to that. So you get the sharing and you get the update of the sharing for free. Now, this is not modular. So this means that when you have another solution, we should think about how do we handle the fact that a tool may change. So from that perspective, it means that browsers may register to the tool environment. So like that, they get notified and updated when there is something that changes. In this way, if you have a registration mechanism, it means that you can load, for example, a new package containing a new tool, and it can declare and say, oh, you know, I'm an alternate browser, I'm available if necessary, or those kinds of things. So it's open more possibility, but we have to pay attention that the solution should take into account that the shared variable should be updated. So as a conclusion, yes, try to avoid to use global. And this is really important in object-oriented design to think modular. Give a chance also to object to specialize messages, because like that, you have a handle to variation. And everybody can decide, every object can decide how to react to a specific message.